A very good morning one and all, and I hope that you followed the previous videos, and I know that you have some information about the classes, ma. So we are going to take the online classes, and if you have any doubts, any one day, okay, in a week, any one day you can come and you can ask, okay. So as I said, here in this numerical analysis paper, we have to know the bisection method firstly, right? So already I gave some information about the bisection method, but today I am going to give some notes and I am going to start the syllabus of the textbook. And you know, in a previous class I gave some information by taking the other example. Now I am going to take the example which we have in our textbook, okay. So now here simply first of all just put a main heading unit 1. I hope you wrote that, right? You wrote some information. So now again in that write down unit 1. So in the unit 1 what we have, errors and errors concept. So in that again what we have, bisection method. So put that one and now write out. Otherwise, if you want to start in a new notes, yes you can, otherwise just wait for one day and again you can start in a new day. If you don't have, then wait. Now write in a rough notes and afterwards you can write in a running notes, okay, main notes. Now here first of all write down, put a side heading, introduction. Introduction, write down. In scientific and in engineering studies, the scientific and engineering studies, a frequently occurring problem is to find the roots of the equation, of the form f of x is equal to 0. F of x equal to 0. Write down in the next line, if f of x is a quadratic, cubic. Quadratic means the order is 2, cubic means the order is 3. Cubic or a biquadratic, okay, biquadratic expression, then the algebraic formula are available for expressing the roots in terms of the coefficient. Okay, now write down the algebraic function of the form fn of x is equal to a naught x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus so on plus a n minus 1 x plus a n. Okay, so is called polynomials, and we discuss some special methods. For determining their roots. Okay, so next write down next line, a non-algebraic function is called transcendental, transcendental function. Example f of x equal to ln x cube. Ln x cube means log, okay, x cube minus 0.7. Next, pi of x, another function, pi of x is equal to e power minus 0.5x minus 5x. Next, psi of x equal to sine square x minus x square minus 2. Okay. Next, write down the real root of equation of f of x may be either real or complex. Okay, so here what they are saying is whatever the function value, sometimes it is equal to 0 and sometimes we can take that it is in polynomial function, and then f of x is equal to, like simply here they are taking that some functions and for these functions. So first of all here if you will take this one, for this we have to find the values of the x. Those are nothing but those are called as roots of the equations. So when we will take the roots, then there is a chance to get the roots are sometimes those are nothing but real, that means maybe positive or a negative, but that should be a real number. Maybe it is a natural number, whole number, integer and rational number or irrational number, whatever it is. Next, or complex. Complex means the number which is in the form of a plus ib. Okay, so they are saying that one. So according to the roots we have to move. Okay, so next put a side heading, ma'am, bisection method. Bisection method. Now write down. This method is used, this method is based on the theorem which states that if a function f of x is continuous between a and b, and f of a and f of b are of opposite signs. Already I gave this information in a previous class, so now again I am giving from according to our textbook, where f of a and f of b are of opposite signs. Then there exists at least one root. Between a and b. Let f of a be negative and f of b be positive. Then the root lies between a and b and let its approximate value given by, already I said na, but there I took that it is p. Now x naught is equal to a plus b by 2. Then the approximate root is x naught is equal to a plus b by 2. Next write down, if if f of x naught is equal to 0, we conclude that x naught is the root of the equation, f of x equal to 0. Otherwise the root lies either if it is by substituting x naught is equal to 0, I mean x naught, if we get it is equal to 0, then we will take that the root is nothing but x naught. Otherwise, now what they are saying, otherwise the root lies either between ax naught or x naught comma b. Okay. So next write down procedure. Okay, now write down. So just write down it as a point wise, and first of all see here, first of all they gives the interval a and b. So according to the statement, this bisection method is introduced by one theorem, that is nothing but for the interval a and b, and f of a and f of b are nothing but the functions, right? By substituting a we will get f of a, and by substituting b we will get f of b, right? And now here, so if these two has opposite sign, so if one is positive and another one is negative, then only we have to take. Okay. So now here, then there exists, okay, if it happens, then there exists one root. Okay. So compulsory oka root undali, and here how they are taking that simply f of a is negative and f of b is positive, right? And next, if this happened, then definitely the root lies between a and b, and we have to take the first value as nothing but a plus b by 2. After getting this x naught, what we have to do? We have to substitute this x naught in the functional value. Then what we get? We will get the result is nothing but 0. So by if it is equal to 0, then simply what we have to take? Yes, the root is nothing but x naught. Otherwise what we have to do? We have to go for the next procedure. Okay. So next write down working procedure. First point, working procedure of bisection method. Now first write down, choose two real numbers, a and b, such that f of a into f of b is less than 0. Second one, set, otherwise choose xr means x naught, x1, x2 and so on. Okay. Set xr equal to, what I said, x naught is nothing but a plus b by 2. Third point write down. In third point again we have that sub points. Now write down a1, if f of a into f of xr is less than 0, then the root lies in the interval, a comma xr, then set b is equal to xr. That means we have to change the value of the b here. Okay. B equal to xr, and go to step 2. Next, b1, if f of a into f of xr is greater than 0, the root lies in the interval greater than 0 means here, then the root lies in the interval xr comma b. Then now here what is the value of the a here? Set a is equal to xr. Okay, set a equal to xr and go to, again we have to go for the step 2. Again go to step 2. Next C1, C. If f of a into f of xr, f of a into f of xr is equal to 0, it means that xr is the root of the equation f of x equal to 0, and the procedure will terminates. Next, write on one point. In a practical problems means while we are solving, that is nothing but practical problems. So in practical problems, the roots may not be exact. So that condition C is never satisfied. అంటే ఇది మ్యాక్స్ గా మనకి రాదు. ఓకే, ఈజ్ నెవర్ satisfied. In such a case we need to adopt a criterion for deciding when to terminate the procedure. Okay, next line. A convenient criterion is to compute the percentage error. It is denoted by epsilon r, defined by epsilon r is equal to modulus of xr dash minus xr by xr dash into percentage. They mentioned percentage now, so into 100 percentage. Okay, so this is nothing but the information about the bisection method. Now here I am going to discuss one application. So first of all listen, here we have, first of all what we have to check, we have to take that f of a and f of b, then we have to take the multiplication. If it is less than 0, then yes, we can proceed. Next what we have to do, x naught, that means our value starts from 0. So we have to calculate x naught. Again next what we have to do, here we will get x naught now. So by substituting x naught we have to find f of x naught. Next we have to take the product of the f of a and f of x naught. Then if it is less than 0, then we have to go with this one. Okay, and if it is greater than 0, then we have to choose this one. Next, if it is equal to 0, then that is nothing but the required root. Okay, next write down problem. Find a real root of the equation. Find a real root of the equation f of x equal to f of x is equal to x cube minus x minus 1 equal to 0, equal to 0. Okay, actually here they mentioned this one only, but they didn't mention that the interval. And here in of course in our textbook they mentioned another one, that is since f of 1 is negative, right down, since continuation, since f of 1 is negative, f of 2 is positive, f of 2 is positive, comma, a root lies between 1 and 2, a root lies between 1 and 2. Okay, so now here we have to find that the solution. Okay, now first of all here what they mentioned, the function is nothing but f of x. Okay, so now here what is the interval, that is 1 comma 2, it is nothing but a b. And here f of 1, f of 1 means 1 cube minus 1 minus 1, which is nothing but 1 minus 1 minus 1 plus 1 minus 1 will be cancelled, minus 1, which is less than 0, that means it is a negative. Next f of 2, 2 cube minus 2 minus 1, now 8 minus 2 minus 1, 8 minus 3, that is 5, which is nothing but greater than 0, that means positive. So like this we have to say that the sign is a positive or negative. So now here what I have, f of, therefore f of a, that means f of 1 into f of 2 is equal to minus 1 into 5, which is equal to minus 5, less than 0. So first condition is satisfied. Next what we have to do, we have to find that x naught. X naught means a plus b by 2. What is a? 1 plus 2 by 2. Now it is nothing but 3 by 2, which is equal 1.5. Therefore x naught is equal to 1.5, right, because 2 ones are and next 5s are. Next what we have to calculate, f of x naught, that means 1.5 whole cube minus 1.5 minus 1. Already I said to solve these problems we have to know, we have to use the calci. Now 1.5 whole cube means, listen, without calci now I am doing 1.5 into 1.5, 5 5s are 25, 5 1s are 5, 6 7, next 15, now 5, 12, 2. Now after how many digits we have points, 1 and 2, so that is why it is nothing but 2.25, again into 1.5, 5 5s are 25, 5 2s are 10, 12, 5 2s are 10 again, 11, next 2 2 5, next 5 7 3 3. Now after 3, that means here the value is nothing but 3.375 minus 1.5 minus 1. Okay, so now it is nothing but 3.375 minus 1.5 minus 1, that is minus 2.5. Now I am taking the subtraction, minus 2.5. Here if we do not have any value, simply we have to keep the zeros. Now here 5, 7 and here we have to take the LCM. So now here what we get, 13 minus 5, 8. Now it is 0. Okay, if you have any doubt then you can take the 2.5 plus 0.875. Now it is 13 and 3. Okay, like this also you can. Now what will be the answer? 0.875. So here f of x naught is equal to this one, that means it is a greater than 0. So it is a positive now, so it is a greater than 0. So now what we have to check? We have to check that it is a positive. Positive means again what we have to do? We have to take that f of a. F of a means minus 1 into this one. Then what we get, which is less than 0. So now otherwise see, I will say in a simple way. Now here f of a is negative and f of x naught is positive. So therefore the root lies between one positive value and one negative value now. So now here it is a positive or a negative? Positive value, right? So if it is a positive, now you have to ignore this one and we have to take one negative and one positive now. So that's why the root lies between a comma x naught. What is the a value here? 1 comma 1.5. Okay. So now here what we have to do? So next again we have to go for x1. So now here x1 is equal to 1 plus 1.5 by 2. Now it is 2.5 by 2. Now it is 1 point. So 2 2s are 4. Okay. Next 1. That means 5. 1.25. Next what I have to calculate? F of x1. So actually it is nothing but up to here. This is iteration 1. Okay. Now here from here iteration 2. So now here we have to calculate f of x1. F of x1 means 1.25 whole cube minus 1.25 minus 1. Now 1.25 into 1.25. Again 5 5s are 25. 5 2s are 10, 12. 5 1s are 5, 6. Now 10, 4, 5, 2 1s are 2. Next 1, 2, 5. 5, 2, 10, 16, 4, 5, 1. Next after 4, that means 1.5625 minus 2.25. Now here I am taking that the value. Okay. Now it is nothing but minus 2.25 and 1.5625 0 0. Okay. Obviously we will get that here negative. So negative means here what I will get? From here 9, 10. It is 5, 9 minus 2 is 7 and again here we have to take that the LCM 4, right? That means 14 and here 8, again from here 11, that means 6 and here 0. Okay. So next here what we get? The value is 0.6875. Is a positive or a negative? Negative. Okay. Now here what we have to write? The root lies between. So now here what we have to do? We have to ignore that part, just we have to see this one. For this a what we have? Negative, and for this x naught we have a positive. Now which one we have? Negative. Now next the meaning of this one, we have to ignore a value. So now in the place of a what we have to take? 1.25 comma 1.5. Okay. Again we have to go for iteration 3. So in iteration 3 what we get? x2 is equal to 1.25 plus 1.5 by 2. If you have calci then it is somewhat easy, it takes some less time. Okay. Now here what we get? 1.75 by 2. Now 0 point, right? Next what we get? 17 means 8 and 15, that means 7, 5. 0.8. So now here if you observe this one, the value of the x, so here 1.5, and see please check this one again. Yeah, 1.75 and next 0.8, correct only. 8 and 16, 15 means 7 and 5. So like this we will get, and next you have to substitute that f of x naught. So I think it is clear to you, but again what I will do is, now what I did, I took with a normal calculation, but I will say with a calculation part with calcium. Okay, then please write this problem. Okay, until then just try to understand this one, and tomorrow I will discuss with a calcium. ఎందుకంటే క్యాల్సీకి దీనికి కొంచెం డిఫరెన్స్ ఉంటుంది. ఓకే, సో టు షో దాట్ వన్ డెఫినెట్లీ టుమారో we will discuss this application with a calci. So what you have to do, you have to maintain the calci also. Okay, thank you everyone. I hope it is clear to you, the procedure is clear to you, and tomorrow we will discuss this with calci. Okay, with calci is very important. Okay, so thank you everyone, have a nice day.